In the 1960s, surgeons severed the corpus callosum of epilepsy patients to stop seizures. The patients seemed fine, until Roger Sperry showed their two hemispheres could no longer communicate, revealing that each half of the brain has its own perceptions, memories, and even preferences. The human brain is divided into two hemispheres connected by the corpus callosum, a massive bundle of nerve fibers. While the hemispheres are highly similar in structure, they show functional asymmetries, specialization for different cognitive tasks, that have fascinated neuroscientists since the 19th century. In approximately 95% of right-handed people, the left hemisphere dominates language production and comprehension. Broca's area in the left frontal lobe controls speech production. Damage causes expressive aphasia. Wernicke's area in the left temporal lobe processes language comprehension. Damage causes receptive aphasia. The right hemisphere specializes in spatial processing, recognition of faces and emotional expressions, musical ability, and holistic pattern perception. Right hemisphere damage can cause prosopagnosia, the inability to recognize familiar faces, and neglect syndrome, where patients ignore everything on the left side of their visual field. The corpus callosum contains roughly 250 million nerve fibers and allows rapid communication between the two hemispheres. It enables the hemispheres to share information and coordinate activity. When severed, as in split brain surgery, the two hemispheres function as largely independent systems, each unaware of what the other experiences. In split brain experiments, Sperry presented images to one visual field, and thus one hemisphere, at a time. When a spoon was shown to the right hemisphere, the patient could pick it out with the left hand but could not name it. The right hemisphere knew the object. The left hemisphere, which controls speech, did not. Michael Gazzaniga identified the left hemisphere's interpreter module, the system that generates explanations for our behavior. When the right hemisphere caused a split-brain patient to laugh, the left hemisphere, unaware of the true cause, invented an explanation. "I was laughing at you." The interpreter creates a coherent narrative from incomplete information. Neuroplasticity is the brain's remarkable ability to change its structure and function in response to experience, learning, and injury. New synaptic connections form, unused connections weaken, and cortical maps reorganize. Plasticity is greatest during critical periods in childhood but persists throughout life, enabling learning and recovery from injury. Eleanor Maguire found that London taxi drivers had significantly larger posterior hippocampi than controls, a region involved in spatial navigation. The longer a driver had been navigating London's complex streets, the larger this region. The brain physically expanded in response to sustained navigational demands, demonstrating experience-driven structural plasticity. Phantom limb pain, feeling pain in an amputated limb, arises from cortical reorganization. The somatosensory cortex area formerly representing the lost limb is invaded by neighboring cortical regions. Touch on the face triggers sensation in the phantom hand because facial cortex has expanded into the vacated hand area. Plasticity can produce suffering.